short fibers are separated to enhance strength and uniformity. Breaks apart compressed cotton to restore fiber volume.
Interlacing of warp and weft forms the fabric structure.
The inspected fabric moves to the packing stage.
Here we see the raw cotton being fed into the massive looms, a continuous process where thousands of threads are woven together at high speed. Fabric production begins as compressed cotton bales are opened, allowing the fibers to loosen for further processing. Fabric production begins with raw cotton bales delivered to the factory floor for initial handling.
Forklifts transport tightly compressed cotton bales to the opening area of the production line. Each bale is positioned precisely to ensure a smooth and controlled feeding process. Protective coverings are removed to expose the raw cotton fibers for processing. The bale opener gently breaks apart compressed cotton to restore fiber volume. Loosened cotton fibers are evenly distributed onto a conveyor for consistent flow.
Several bales are processed together to maintain uniform fiber quality.
Automated sensors regulate the cotton feed rate to prevent overloading. The fibers move into the opening chamber, where further separation begins. Rotating beaters break down fiber clumps into smaller, manageable sections. Loose dust and surface impurities are released as fibers are opened. Powerful extraction systems remove dust to maintain fiber purity and air quality. Cleaned fibers are transported toward the mixing section for uniform blending.
Blending fibers from multiple bales ensures consistent fabric quality.
Control systems precisely adjust blending ratios for uniform results. Airflow systems gently transport fibers without damaging their structure. Secondary opening further separates fibers for improved alignment. Precision rollers refine fiber separation while maintaining length integrity. Remaining impurities are removed and collected for disposal. Quality sensors monitor fiber consistency in real time. Prepared fibers are temporarily stored to balance production flow. Level sensors ensure a steady and uninterrupted supply to the next machine. The opened and cleaned cotton fibers are now ready for carding. The carding process begins as opened cotton fibers are fed into the carding machine.
Feed rollers distribute fibers evenly to ensure consistent carding. The main carding cylinder uses fine wire teeth to separate and align fibers.
Cotton fibers are lifted and spread to remove tangles. Flat bars further comb the fibers, improving alignment and cleanliness. Extraction systems continuously remove unwanted particles from the fibers. Cleaned and aligned fibers move toward the Doffer cylinder. The Doffer cylinder gently lifts fibers from the carding surface. A thin, continuous web of fibers is formed after carding. The fiber web is condensed into a soft, rope-like sliver.
Combing begins as slivers enter the combing machine. Combing rollers straighten fibers to improve yarn quality. Fine combs remove remaining short fibers and imperfections. Short fibers are separated to enhance strength and uniformity. Only long, high-quality fibers continue through the process. The refined sliver moves steadily toward collection. The carded and combed sliver is now ready for drawing. Drafting rollers rotate at varying speeds to stretch and equalize the sliver.
Several slivers are combined to improve uniformity and consistency.
The sliver becomes thinner and more uniform during drawing. Sensors continuously monitor sliver weight to maintain quality control. Automatic controls fine-tune drafting speeds for precise results. The equalized sliver exits the drafting zone smoothly. The sliver is gently condensed to stabilize its structure. The drawn sliver coils evenly into collection cans. Roving begins as drawn slivers enter the roving frame. The sliver is further stretched to reduce thickness. A slight twist is added to give strength to the roving. Tension controls ensure smooth and stable roving formation.
The roving is wound evenly onto bobbins for spinning.
Multiple bobbins operate together to maintain production speed. Finished roving bobbins exit the machine, ready for spinning. Roving bobbins are organized for efficient transport. The roving is transferred to the spinning section. Operators visually inspect roving quality before spinning. Only approved bobbins proceed to the spinning stage. Only approved bobbins proceed to the spinning stage. The prepared roving is now ready for yarn spinning. Yarn spinning begins as roving bobbins are loaded onto the spinning frame. Tension guides control the roving flow before drafting. Drafting rollers stretch the roving to achieve the required yarn thickness. The roving is drawn out to form a fine, even strand. Twist is applied to bind the fibers together into yarn.
Continuous yarn formation takes place at high-speed spindles.
Hundreds of spindles operate together to maintain production output.
Balloon control rings stabilize yarn movement during spinning. Automatic lubrication reduces friction and machine wear.
Finished yarn is wound evenly onto bobbins.
Sensors monitor tension and speed to ensure yarn quality. Stop-motion systems immediately halt spindles when breaks occur. Broken yarn ends are quickly repaired to minimize downtime.
Production resumes immediately after repair. Bobbin filling continues steadily during spinning.
Spinning frames run continuously to meet production demand.
Air suction systems remove lint to keep machines clean.
Inline sensors check yarn thickness in real time.
Operators monitor machine parameters to maintain quality.
And we have this always made for air.
Bobbins are filled to a preset diameter for consistency.
Automatic doffing prepares to remove completed bobbins.
Completed yarn bobbins are removed from the spinning frame. Empty bobbins are placed to continue spinning without delay.
The spinning cycle resumes immediately for uninterrupted production.
Finished yarn bobbins move to the winding section.
Conveyors transport yarn efficiently within the factory.
Bobbins are grouped for traceability and quality control. Each batch is tagged for tracking through later processes. Temporary storage balances spinning and winding operations. Yarn samples are taken for quality testing.
Strength testing ensures the yarn meets specifications.
Approved yarn bobbins proceed to the winding process. Any defective bobbins are separated from production. Quality-approved yarn moves toward winding. Bobbins are mounted onto winding machines. Winding machines start preparing yarn for weaving. Yarn ends are threaded to begin winding.
The spun yarn is now ready for fabric production. Warp yarn packages are mounted onto the creel to prepare longitudinal threads.
Tension guides align warp yarns for controlled feeding. Pedals control the vertical movement of warp threads. The reed maintains spacing and alignment of warp threads. Weft yarn is positioned to interlace with warp threads.
The loom begins operation by opening the shed.
The reed beats the weft yarn firmly into the fabric.
Interlacing of warp and weft forms the fabric structure. Newly formed fabric advances steadily during weaving.
The weaving cycle repeats continuously for uniform fabric.
Edge guides maintain consistent fabric width. Tension sensors ensure even fabric formation.
Broken yarns are repaired immediately to resume weaving.
The fabric roll builds steadily during operation.
Continuous inspection ensures surface uniformity. Fabric rolls are produced to precise length specifications. The loom slows as the fabric roll nears completion. The finished fabric roll is separated from the loom.
Fabric rolls are secured to protect material integrity. Each roll is labeled for tracking and quality control.
The fabric roll is positioned for detailed inspection. The finished fabric roll is mounted onto the inspection machine. The fabric is unrolled at a controlled speed for inspection. Special lighting highlights surface defects and irregularities.
Operators visually inspect the fabric for defects.
Magnification helps identify fine surface imperfections.
Detected defects are marked for quality grading.
Fabric advances steadily through the inspection zone.
Inspection data is recorded for quality documentation. Automated sensors monitor fabric width and tension. Approved fabric continues to final finishing.
Rejected sections are isolated to maintain quality standards. Inspection continues until the full roll is completed. The machine slows as inspection reaches the end of the roll. The inspected fabric is rewound evenly.
Edge alignment ensures uniform fabric rolls. The inspected roll reaches its final diameter. Inspection labels are printed for traceability. Inspection results are attached directly to the fabric roll.
The inspected fabric moves to the packing stage.
The inspected fabric roll is protected with industrial wrapping for storage and transport. Edges are sealed to prevent damage during handling. Finished rolls are placed on pallets for organized storage. Pallets are transferred to warehouse storage, awaiting dispatch. With inspection complete, the fabric is ready for delivery to the market.